Talking about limit of, for example, two variable functions, you either have some nice functions that you can easily find their limit by substitution, or some other times, which is the majority of time, you have not well-behaved functions. You have to apply some techniques, some methods to be able to identify the limit or show that the limit doesn't exist. So limit of two variable functions. So we can categorize this, classify this into scenarios, nice functions. So let's see. If you have nice functions, you can easily find the limit by substitution. You can find the limit by simple substitution. Give us an example. For example, if you have a function like f of x and y equals to x squared plus y squared minus 2xy, and I ask you to find the limit of f of x and y as x approaches 1 and y approaches, for example, -1, what are you going to do? You're going to say that, hey, I have a linear combination of x, y, and their, for example, exponents. So simple substitutions help me to find the limit. It's going to be equal to 1 squared plus 1 squared -1 squared minus 2 times 1 times -1. So you get 1 plus 1, and you get plus 2, which is 4. 4 is the output value of your function, or the limit of the function in this case, and it is a z value. So this is our conclusion. As x and y approach 1 and -1, z value is getting closer and closer to 4. Then z gets closer to 4. And since you have a nice function, the output value of the function is the same as the limit of the function. Some other times, we don't have a nice function. For example, not nice functions, like what? Suppose I give you a rational function like this. My f of x and y is defined as x squared minus y squared divided by x squared plus y squared. And I ask you to find the limit of f of x and y as x and y approach the origin, 0 and 0. Okay, very good. Your very first reaction is substitution. Let us substitute first. Zero squared minus 0 squared divided by 0 squared plus 0 squared is 0 over 0. As we learned before, this is not equal to 0. This is indeterminate form. Indeterminate form. So what's the meaning of that? It means that the limit is indeterminate form? Of course not. Now you have to apply some new techniques that is developed for you for multivariable functions. what you're going to do, you're going to approach to the origin from two different paths. We're going to take two paths. The very first path is x equal to 0. I'm going to set x equal to 0. It means that I am on y-axis. If my x is equal to 0, this function is reduced to f of 0 and y, which is 0 minus y squared divided by 0 plus y squared, which is negative y squared divided by y squared, which is negative 1. The second path, I'm going to set y equal to 0. When y is equal to 0, my f of x and 0 is equal to. Here your y is 0, so x squared divided by x squared is going to be just 1. So here, let me just move it a little bit here. So let me write. Sorry. So for this guy, you have 0 minus y squared over 0 plus y squared, which is negative 1. And here you have x squared minus 0 over x squared plus 0, which is just 1. Here, we've got two different z values. The limit must be unique. The limit must be just exactly one number. When you have two different numbers, it means that the limit of this guy around the origin doesn't exist. So here you're going to write down, since 1 is not the same as negative 1, it means that I get two different z values. What's the meaning of that? It means that the limit does not exist. So this is the two-path method. Sometimes two-path method works nicely, like this scenario, this case that you actually see. Some other times it's not working that much. So instead of taking just two paths, we're going to take many general paths.